Hello, this is litaochen. My project is about predicting patient show up or no show of appointment based on historical data. This course is SI E29 from Harvard Extension School, offered in spring of 2018, and this is our teaching staff. Basically, the dataset I'm using is from Kaggle. It contains 110K medical appointments and is 14 variables of each. So our mission is to basically analyze the data and visualize do some visualization to capture the important features of the dataset. And based on the analysis, we do a feature engineering and build a model to predict show and no show. So here's the required libraries and files. Nothing special. We use pandas, numpy, matplotlib, seaborn, and plotly. And dataset can be found from the link here. And you can also download the Jupyter Notebook from the repository list at the bottom. Okay, so let's jump to the code. And let's go back to the top. So as usual, the first step, we input libraries and we load data. Then you can see it contains about 110K records with 14 features. And we then check if the data is clean. So basically, luckily the data is cleaned. There's no null value here. And here's the data type. So we want to change a few of them. For example, the patient ID currently is the float. We want to change to a string. And for the schedule day and appointment day, currently they are strings. We will convert them to datetime for the future manipulation. And then the conversion is done. So everything all right. All the others should be fine. We don't touch it. And then we have a quick look on the numbers in the table. And then let's take a closer look on the data we got. First, we can see that we have 88K records for show and only 22K records for no show. So this data set is not balanced. And how about age? So we have many newborn babies, and then it goes up and down to 80s. Then the number of population is coming down. So what may affect patients' behavior? So that's maybe the combination of all of this. So then let's take a look on each factors and to see what features we should use when building the models. So the first thing is, the question in my mind is that will people at a certain age tend to skip the appointment? So here's the line chart. The red line means the count of no-show at a certain age. And the blue one means the count of show up at a certain age. And it looks like that in this area, we have lower no-show ratio comparing to the younger people here. So maybe age is a good feature for a model. And then how about waiting time? So if the waiting time is too long between schedule date and the appointment date, people may tend to forget the appointment, or maybe have some emergency happened, they cannot go to the appointment. If we analyze this with the people table, we can see that if for the group that didn't show up for their appointment, the median waiting time is 10 days. But for the people they show up, it's just 1 day. So that indicates maybe the waiting time between the scheduled date and appointment date, then that can be a good feature for the prediction. Here's just another view of it. And another question is, do people tend to skip appointment in a particular day of a week? Then we just do some analysis and visualize it. Here's the result. From this figure, we don't really see clear trend here. From Monday to Friday, the ratio is almost always 4:1. Don't see clear trend here. So this may not be a useful feature. Then next question is, does SMS notification help reduce the no-show ratio? And the results kind of surprising for me, because if you look at here for the group that did not receive any SMS notification, the ratio between no-show and show is around 5 to 1. But for the people who received SMS message, I expect we should have lower ratio of no-show, but here we see a higher ratio. It's about 2.5. Yeah, it's kind of surprising. So one possible reason might be that not all the clinics provide SMS notification, so this feature might not be a good candidate for the model. So how about gender? If we analyze the gender here, if you take a look at the number, I don't see really any trend on the gender regarding the show or no show. Okay, so now let's try to do the prediction. And the model I want to try is the random forest classifier. I tried a few, but this one tends to give me a kind of good result. Now first, we're going to prepare the data. We're going to transfer these three features into dummy numbers for the model to calculate. Then we just import libraries. We include these features, and we prepare a data set and train it and do the prediction and print out the result. Here you can see the accuracy is 0.76. Looks okay, but if you look at the confusing matrix, it's really not that good. This one is okay, but when you're predicting the no-show, the accuracy is kind of low. And I've played with it for a while with different arguments or hyperparameters, but it's not significantly improved. And probably the imbalanced data set contribute to this problem. And this is what I got in the end. Thank you. That's all.